Okay, so now that you have the Dynamo set up and energy analysis for Dynamo is here, let's see how you can run an energy simulation within Vasari first. Uh, I want to show you the logic first, and then the development there is very similar in Dynamo. So it takes the same logic, port it to a parametric environment, so you have more flexibility how to set up the model and run iterative analysis and all that stuff. But the logic is the same. Before I forget, one more thing. Make sure your view is not in perspective. So select 3D view, 3D, go to analyze, not analyze, manage. And here, if it's on perspective, change it to orthographic. If it's orthographic, then you're fine. If you forget this one, you will be reminded pretty fast because the story will crash. So, not a big deal. Uh, Now you have this thing all set. And I should add, it will crash when you're working with Dynamo. It doesn't crash like if you're only working with the story. I just select one of these boxes. Let's do this one, which has a direction. Good, it's not a square. So just drag it here. Let's place it somewhere here. Okay, now I have a mass. So the way it works in Vasari is when you have a mass family like this, you apply the mass floors to it, the or levels. The levels are already made, right? I just select them. You can select all shift or all the stuff. That's okay. I just selected them. Now, if you check it here, I have some floor mats. And this is now kind of like it's not only a dumb box. So it's a mass, it has some floors. So having this, you have this cool feature here in Visari that lets you set up the energy setting for your model. And keep in mind, setting is global. It's just in a project level. For your excuse me, for your project, you have one energy setting. It means all your glazing are 40%, right? All the buildings, all the masses that you have will inherit all this setting from here when you create an energy model. You have access to systems, you have access to schedules somehow, somewhat, and the other stuff that you can see. So I'm not going to change anything right now, but I'll just show you how when you change it, it changes your energy model. So if you're fine with that energy setting, what you would do here is you say, okay, enable my energy model. And what will happen, the starter will go and start auto-zoning your mass, and you see it creates the perimeter zones, core zones in different floors. And now every single of these ones are kind of a representation of a thermal zone which can be sent for energy modeling. The way Vasari works is you can say run energy simulation, which I'm not going to do it right now. Uh, and once you do run energy simulation, it exports this mass as a GBXML file. Again, if you don't know what is GBXML, you can look it up, right? It's Green Building XML, which is a schema for interoperability between different softwares. Here they say Beam software, and mainly people using it for energy modeling, but there is more than that into it. People are using it for different stuff right now. So what happens is the story will export a GBXML file, and why it will export a GBXML file? Because Autodesk has this Green Building Studio, which is a web service that lets you run energy simulation on the cloud. So they create a GBXML file, upload it basically to Green Building Studio, and run the simulation inside Green Building Studio, and then give you back the result. So I show you the Green Building Studio 2. Studio. Here. This is the website of Green Building Studio that you can sign in, and I have probably to sign in at some point to show you how it's working. That's it. So now I hope you have an understanding about the process. So it's you set up some energy setting. You create your energy model. You say, okay, run the analysis for me, which basically means create a GBXML, send it to GBS, run the analysis, give me back the results. So you have here result and compare. If you have the results, you can say, now I think it's a good time to show you like how energy setting basically rules this energy model. If I do 60% versus 40% and press OK, you will see that this thing changed to be 60% as it used to be 40%. Now you start to think, okay, what if I want to have 60% on the south and 10% on the north? Well, there is a way. You can change the way you can select the mass. You can select zone by zone. Then you can go to the setting and say, okay, this zone make it 40%, this zone make it 40%, or I said 10%, or whatever. And you know, that's where it sounds really painful, I know, and that's where this Dynamo and any kind of visual scripting are going to be handy and useful. So let me show you how to do that. I disable energy model here. I delete all the level from my model. And I put this in here. I try to do half. Okay, works perfectly. So I have Vasari on the left hand, Dynamo on the right hand. So as I mentioned, first I want to set up my energy setting. So if you look at here, you get energy setting on the top. And inside energy setting, you have a node, energy setting actions called set energy setting, which lets you set the settings that we just saw, and you could set it up from here, right? So now you can set it from here using a slider, for example. So, and then you can change it if you want. So for now, what I would do is I'll just use get energy setting, which is another node that we have. I'll run this. And when I run this, this one returns all the values that we have right now for the energy setting. So it's an office. Lighting percentage is 60%. If you remember, I changed it to 60%. Then shading depth is 0.6. Like central, this is the HVAC system that you have, and the schedules are set to be default, right? Now let me go ahead and change the shading depth to be 0.4 instead of 0.6, and glazing to be 0.8, using 0.6. And I connect this in here, I connect this here. And because we successfully loaded this drop downs, I just show you how to do drop down. So this building by default will be an office. Let's go ahead and instead of an office, make it to be a hospital or a museum or hospital. So now if I press run, you will see that that thing is changed. Shading depth is 0.8 now, right? And glazing percentage is 0.4. So if I go ahead and make an energy model out of this, it will be based on this input. I mean, I don't really need to keep them here. It's just like a node that sets the parameter. So you can easily get rid of it and keep doing what you want to do. You can keep it there. It doesn't really matter. I just removed it to keep my screen clean, and I don't really have a bigger screen here to have extra stuff. So again, we set the energy setting. So what we want to do next, we want to prepare our model. Then we want to run the analysis and get the result. So let me prepare the model. To prepare the model, what I need first is to bring this element to Dynamo. For doing that, you don't need to use energy analysis for Dynamo package, but you just use Dynamo nodes, native nodes, which called I think select model element. select model element. What this node does, it lets you select one of the elements. So now I selected this element. I have access to this family inside my Dynamo. Now I have this. I need to create some levels. As if you remember, we had the levels. So I will generate my levels parametrically too. And there are different ways that you can create level. I do it by elevation. And for elevation, I go and do it by, let's say, every 3 meters. And this one is 21 meters. So what I need to do is, this is a really cool feature I think Code Block does for you. You can type 0, which is the start, to 21, and then the step is 7. Oh, yeah, the step is 3 meters, 3. So it will generate all the numbers for you. If I run this, you will see 0, 3, 6, 9, 12, up to 20, 21. It's all generated by writing this. Can you see it? It's all generated by writing something like this. Okay, so now I have this as the numbers. If I connect this here to elevation, it will create my levels, and I have my model. So there should be a node here that basically takes these two and create an energy model. It's called create energy model from mass and levels. This is only from mass. This is from, there were three options. I was like, this unlucky. So this creates an energy model for you from mass and levels. If you don't want to type, I mean, when you want to get started, probably you want just to check. So you should go here. You should check prepare energy model, and then you can see here you have, I think, you can create an energy model from mass and level. You can create an energy model from mass. I'm using this one for now. You can decompose them. You can see all the set of stuff that you have. So let me go ahead and create this. I connect this here, I connect the other one here for the levels, and then I run. Once I run this, if you check here, here we go. So I got my energy model ready, and it has, if you remember, I did the shading depth of 0.6, so everywhere has shading. And I put 0.4, I think, as the percentage of the glazing. So it was as simple as this. Now, if you want to change the levels, you can change it here. You can say, okay, I don't like really 3. They changed it. We want to do every 4.2. You can run it again. You have the new model. So far pretty cool, right? You have control on your energy model parameters parametrically. You can change it. So from here, I just said, oh, this is cool, but I want to have different percentages in different directions. How can I get that? Let's say let's just do it. Let's do it. We want to have more glazing on the south and the north, and less glazing on the east and the west. So let's think for a second. How do you do that normally? If I first of all I need to understand the direction of this surface, and then I should check and say, okay, if you're facing south, I want you to be 80%. If you're facing north, I want you to be 80% too. If you're facing east or west, I want you to be only 10%. So how can I do that? If I have access to the vector of these surfaces and then compare the vector angle with the north, then I will have a really good idea about that, right? The direction of my surface. So let's do that. One of the outputs of this node when it creates this analytical model or energy model is it gives you access to the wall surfaces and roof surfaces. So I have all my wall surfaces here, and if you check here under prepare energy model, there is analysis surface vector. What analysis surface vector does is if you connect a surface to it, it will return the vector of that surface. So cool, I got the vector that I needed to compare. Now the only thing I need is to have a vector for the north, which is the y direction. So I just type here vector y-axis. And here we go. Now I got a vector with y-axis. Now I need to do a comparison between these two, which in this case I will use vector dot. I connect the list of vectors coming for all my walls here. I connect north direction here, and it will return doubles for the dots between the two vectors. And now I can use this range of numbers. Let me run it, and actually let me save the file. So I go to desktop here, and I say, oh, 0.1. Save. So now if I run this, you will see it will return values between -1 and 1. Just run this. And in theory, how Dynamo works is if you have no change to this node, it won't rerun that node. So it's not like it will be really slow or something. If you make a change here, it will just compute these two and keeps whatever output this one has. So now if I check, as I said, I get values between 1, -1, 0. Basically 0 is kind of north, 1 is south. Uh, no, 1 is on the side, -1 is south. So whatever. I think I'm wrong, but it doesn't really matter. What does really matter is I can use these values between -1 and 1 and map them between 0.1 and 0.8, which is the percentage of the glazing that I want. For that, you have remap range node. You can connect these values here. You can say new minimum is 0.1, new maximum is 0.8. So something will go wrong here. Do it. We will see it goes wrong, and then we will fix it together. So if I run this, nothing happens. I run it again. Yeah. So what I would do, I just remove this here. Oh, I'm so sorry. I'm not mapping anything on top of this. So I get confused. Okay, my bad. Sorry for the confusion. It was happening. It's generating these numbers, but I have to put these numbers on top of this geometry to see the change. I wasn't doing that, and I was expecting something. Okay, it's good. So you can see like how you can make a mistake. So here are the numbers that you have now mapped between 0.8 and 0.1. Now, if I connect this, if I use these values as the percentage opening for my surfaces, so again, I had a list of surfaces. I found the angles, not angles, the vector dots for every single surface that I had. I remapped them between 0.1 and 0.8. So now I want to use this number to set the parameters of this surface. And there is a node for that. So just type set wall surface parameter. And we have a set wall surface parameters. If you are using the older version, which is coming from the download link, you don't have set wall and set roof. This is something that we added recently. So you will have set surface parameters. And it's not that different. The only difference is, actually, it's not different at all. Like the one you will get with, only the name will be different on your case, which is fine. So what this one lets you do is if you have a surface ID, it lets you set up the parameters for that exact surface separately. So what will happen if I connect my surface IDs here and connect my glazing percentages here. So for every single surface ID, I have a unique value of percentage for the glazing, which I generated parametrically by comparing the vector angle. So I run this. Here we go. We got it. And I said something should go wrong. And what went wrong is I said I want to have big windows on the north and south, but a smaller one on the east and west. But you can see on the south, I get really small window. And because this is the where it returns -1. So what I want to happen is I want -1 and 1 to be treated the same, which is what we call as absolute, right? So I want the absolute of the number instead of the number itself. To get the double, I pass it through the absolute. For what absolute does, if you pass 1, it will return 1. If you pass -1 or any negative number, it will return 1. If you pass -2, it will return 2. This is how it works. So I connect it here. Now it should return 1 for both north and south. So on the both sides, I should see big windows. Let's try see if it works. Here we go. So now I have bigger windows on both sides, north and south, and east and west. You can see it's smaller. So here's an example how to control. I don't want to go crazy here, but you can do the same thing for shadings, right? You can say, okay, but this time you can say put no shading on the north, big, like largest shadings on the south, and then some shading on the east and west. So to do that, it's pretty simple. I'll do it if you couldn't follow, it doesn't matter. So I just copied this. I don't use the absolute number. I use the numbers itself. And for minimum and maximum, I should do it reverse, right? Why I'm doing it reverse? Because where I want the biggest shadings returns the minimum number, which is -1. And now I can connect this to the shading depth. So now if I run it again, now you can see all the shadings are the same all over the place. But that's not a good design. So we just change it. So now if you see, like I have the big shading here, or deep shading here to be more accurate, and the smaller ones here, and no shading here. Almost no shading because they didn't put the minimum at 0. 0 here. And now if I run it, anyway, so I'm just showing you how you can set it up. Now you have your energy model basically set up. We are done with this part, enable energy model and energy setting. And I hope you saw how this set of nodes helps you to customize the way you want to prepare your model. I think I stop this video here and I do another one to show you how to run analysis, basically prepare the analysis and run it on the cloud and get the result back. Thanks for watching.